right. Okay, in these videos, we'll be going over the dilation factor from the y-axis using Desmos demonstrations. I'll cover here the two examples that I gave from my previous videos, right? So, in these videos, we'll be analyzing the dilation of the point 3,4, which is here, from the y-axis. So we'll be moving it away from the y-axis depending on the value of k, this k, right? The value of k, this one, sorry, not that one. Right, so what I've done here is I have labeled the O point as x old and y old, so which are 3 and 4, and which is in here. And I created a new x point labeling k times x old, which is the general rule, and then the y new is the same as the y old, as we have seen from the previous videos. So what happens when we dilate from the y-axis? Okay, let's see what's happened with the value of k, right? So if I change the k value, let's say I'm changing k is 1.6, meaning it's going to move away since it's bigger than 1. And as I increase k more and more, the point 3,4 diverges away from the y-axis further towards the positive x-axis, right? So as you can see, as we increase the k, so does the x value moving away from the y. As we decreases the k, the y, this point, which is the new point, will approach towards the original point. Okay, observe that. And as soon as I reach to k equals to, let's say, 1, over here k is 1, the 2 points coincided, okay? And that's because k is 1, and 1 times x, it doesn't change anything. It's a unity. 1 is a unity, multiplicative unity. That's why we don't see any changes. And as I decreases k towards 0, the point get closer and closer to the y-axis, and then as k reaches to 0, we have the value x equals 0, 4, right? It's because k is 0 and 0 times x is 0. That's what we get. We sit on the y-axis when k is 0. And you may be wondering, can we check k being negative? The answer is yes, but we want to think more of like k being positive because we're factoring it away from the axis. Negative would just reflect it across the y-axis around here. It will have the same effect, just in the opposite direction of the x-axis. So let's see what I mean. Okay, I'm gonna change k boundary to, let's put into negative, let's say 3. Now watch as I change the k values, okay? So there. Now I'm gonna let k to go to the left of 0. So you can see it's moving away from the y-axis in the negative direction of the x, right? You can see there, it's moving it away. And now as I increase towards 0, approaching 0, and then diverging away between 0 and, when k is between 0 and 1, the value would be between the original point and the y-axis. And as soon as k get bigger than 1, it will move away from that along the positive x-axis. Right, so that's the point 3,4. Let's see if I change the point to, what was the point that I used? It was, I think, 1,4. So let's change x to 1. Okay. If we do that, we'll see the following. Okay, so I'm going to start from k0. So we sit on the y-axis and moving away. There, keep moving. K is between 0 and 1. And then as soon as k passes 1, it diverges away from the y-axis. So on and so forth there. All right. And if k is negative, it will have the same effect, but in the opposite direction. That's all. That's pretty much it. All right. What if, my question is, what if x, the original point is on the y-axis? What would happen? Let's observe. So what I mean is, that means that x would take the value 0, and we'll say we'll keep y being 4, maybe 3, I guess. Okay, let's take x to be 0, so we're at the point 0 comma 3. So at the moment the 2 points coincided, so let's see k is equal 1. Oopsie. Right, they're the same. If I increase k, right, there's no change at all. See, the 2 points still coincided into each other, right? It doesn't change. However big or small the k is, can you guess why that might be the case? Like, why it doesn't change at all even though we increase the k? In the previous case, it does increase, right, depending on the k. But in this case, it doesn't do anything at all. It just stays there, you know? Not very interesting. But the thing is, the reason why we don't see any diverging away from the y-axis, that's because the x value, which we are multiplying with the k, is 0. So 0 times k, whatever that k is, would remain 0, because 0 times anything is 0. That's why we don't see anything, right? If the x sits on the y-axis, the point sits on the y-axis, sorry, regardless of how big or small k is, will always be remaining on that original point, that it wouldn't change at all anything, right? Okay, let's just change x back into maybe 2, I guess. Now if we change the k, it changes, right? But if x is 0 again, it doesn't. So there you see the Desmos representation of dilation from the y-axis, and I'll put the link in the videos in the video description, and you can play around yourself and get a better understanding if this is not already convincing to you. All right, see you later.